This computer. Okay. All right. So, Tammy, did we have somebody queued up to do the icebreaker thing?
I told you guys that you get to choose if you're doing it or not.
Oh, I
You read all
forgot.
my email, don't you?
I did read your email, but I forgot that piece. Um, and we have all kinds of stuff all queued up for this, but not that. So I don't know if Ellison or Christian, you want to have a quick question, or if we should just take the time to have our discussion.
How about we go straight into discussion? Because I feel like I might have a lot of questions for the rest of the group at the end. You can call that the icebreaker.
All right. So I'm going to share screen. We have a several slide presentation to prompt the discussion. I also am going to break out of the presentation and go to an app that I have that I really liked that shows how things work in houses, and that I think will be helpful for people to really kind of grasp onto what we're doing here. So let's see, let's get the share screen going properly. There it is. Okay. So hopefully you see this. And we are going to go through, so this is just tech team plans and opportunities, and we're first few slides Christian is going to take. So
sounds good. Good. So what we wanted to do today is talk a little bit about, remind people a little bit about some of the things we have coming up. Don't overly read this. This slide is more for reference as much as anything else, and we'll talk about more in a bit. But kind of get the whole team kind of refamiliarized with some of the major initiatives that we think will likely fall under our purview, how these things stitch together, and then how this will actually like ramp out. Because I think if the rest of the group is anything like me, they spend a lot of time thinking about this stuff and really can't remember many of the things that the other portions of the team promised to do as part of the proposal. So hopefully we can get everyone else up to speed a little bit. But at a really high level, how can we integrate some kind of smart-ish technology to improve or protect indoor air quality during adverse outdoor air quality events? I really emphasize on that outdoor air quality event because I want to talk about that a little bit towards the end, because I feel like we have some opportunities maybe with this technology that we might be able to do some other things as well. It's a little daunting when you look at actually how many tasks we have, but hopefully a number of these overlap, and so it doesn't get too crazy. And many of these will have lots of pieces that interact with the broader team in general. But next slide. So kind of putting these things broadly into bins. In my mind, we have three big bins that the tech team is going to be working on. First is this idea that, well, we have these outdoor air pollutants. We talked about forest fires as the main one, but I don't think we actually necessarily need to limit ourselves to that from a logistical standpoint, but that these air pollutants exist and that we're not doing anything to reduce those or eliminate those, but because those exist in the current scenario, they would be getting inside the home because of gaps in infiltration and pressure leakage and open windows and all those things, some of which I think Paul is likely to talk about more. So one fraction of our work is, if we were never going to do an intervention, what was likely going to be getting into the house? Had better estimates of that, better modeling of that. How can we establish what we would anticipate outdoors coming to indoor? And then if we have a second bin of big space that we're working in, we say, okay, we accept the fact that this problem exists. How can we do something about it? So how can we monitor and identify early on that we're likely going to have a problem of outdoor pollutants getting indoors? how can we make a judgment call about that, and how can we implement an intervention. And so the kind of middle bucket, I think we could say, falls into a pretty lab-based approach. How can we do this from a kind of theoretic standpoint? How can we put the hardware together, all of those components? And then the one that really scares me for lots of different reasons is this third bucket of saying, okay, we know that outdoor particles might impact indoor. We think we have an idea. Hey, stranger, let us come into your home and start messing with things. And that's really the third bucket. And one that I think for the rest of the group is going to be a really important one for us to talk about is that's where I think in my mind at least, the rubber is really going to hit the road of all of our teams needing to come together. We should be coming together in bucket 1 and bucket 2, but if we don't have all of our components really squared away, I think well before that third bucket will be in a bad shape. Next slide. I can't remember if I was doing one more or not.
Yeah.
Oh yeah. So there's gonna be a lot of overlap in terms of Paul, Ellison, and I, but one of the pieces I'm kind of heading up is this anticipatory control idea. So this idea that we see outdoor events happen before we see indoor rises in air pollution. That seems to be pretty good. This is some data I pulled from, to be honest, I can't even remember which of the forest fires in the last couple of years we've had. One of the Front Range forest fires we've had the last few years. Lots of other people have seen this as well, so that's not too surprising. One of the things that I've been doing over the last 4 or so months is compiling and putting together a data set so we can start training our algorithms to try and do this anticipatory control. So one component of that has been to pull the entire Purple Air network because they limit how much we can touch their data. So I've just pulled all 1.6 terabytes of their data. So we have a massive data set of indoor and outdoor data that we can play with. I've identified about 180 paired indoor outdoor homes that, at least on my first glance, I think is going to be useful for us. And so we can talk at some point about kind of the criteria that I was using there. But data sets or paired indoor outdoor measurements that I feel really good are from the same location, and indoor data sets that do not look to be really bad air pollution the rest of the time. Like there's some that look like, I don't know, it's a cooking activity or smokers or what, but ones that just look like the indoor data is so very messy and confusing. I don't even want to deal with it. I have another about 3,000 outdoor only sites. This is from the 22,000 Purple Air sites that we have access to right now, that I'm working with as part of my training set. So what I'm doing there is saying, well, if we're going to rely on kind of this low cost air pollution network for our technology, can I, in the Purple Air data, identify adverse air events that I know occurred based on other measurements, EPA monitors, the Air Now network, times that I know there have been plumes going over their communities, that sort of thing. So there's still a lot of work to be done here, but this is the data set that I'm sort of mining my way through right now. One of the risks that I see, or one of the challenges and risks that I see for this over the coming months is it's great to do all these things retrospectively on data sets, but would really love to do this in active real time in terms of, can my algorithm run fast enough? And we're just at the whims of the rest of the world. Do we have a poor air pollution event, that sort of thing going on, that I can test this on. We do have one set of active monitors going on right now on the roof of the powerhouse, where I have paired outdoor, kind of a mini chamber without filtration and a mini chamber with filtration that's running the basic algorithm now. That was developed by one of the REU students last summer. So that's running well-ish, having more issues with the durability of a undergrad student putting together an experiment for the first time, as opposed to the algorithm working. But separating out most of those issues, such as it would turn off when it would rain. So that's fixed. And that's at least a preliminary testing set. And we'll move it towards kind of bigger systems here at the powerhouse in the coming months, if that all works. I think that's the end of my slides.
Okay. So let me go find my app that I wanted to show. There is some switching. Hopefully you'll see a thing that looks like a little house. Have we switched from the PowerPoint to the little house? Okay.
Says two-story house.
Yeah, okay. So what I want to show here is just a little primer of how stuff works in houses. So what we've got here is a two-story house of moderate air tightness. Indoor and outdoor temperatures are currently the same. But if I make the temperature a lot colder, so I'm going to go down to say 20 degrees Fahrenheit, this shows the pressures that act on the house because of the temperature difference. This doesn't include anything about wind. It just includes stuff about temperature difference. And so, at the bottom, we would have, in this case, 3 pascals of pressure negative. So you're getting outdoor air coming in, and then at the top, it's 3 pascals positive. So you're getting air pushing out. And this is why the contaminants outdoors are getting into the house, because something is driving them in. So this is what's bringing the particles in, and the colder it gets, the more it happens, and the warmer it gets, the less it happens, until you get into the summertime and it just switches. Now the stuff is coming in at the top, coming out at the bottom. But so let's just go back to say 40 degrees or so. Now, if I have a fan, let's say that I am going to push air into the house. I'm going to have a supply fan pushing outdoor air into the house. If I do that, then I'm pressurizing the house and I'm gradually shutting off that negative pressure that's bringing the bad stuff in. And if I have enough of it, which this shows I don't quite have enough of it to totally shut it off, then I can essentially shut off the uncontrolled air that's coming in that would have the bad stuff in it. If I made this a 1-story house, now because you don't have as tall of a chimney, the pressures are smaller. If I had a tighter house, then that it's easier to pressurize that tighter house so we don't get as much coming in. So there are various characteristics of the house that are going to drive what amount of flow we would need in order to essentially zero out any amount of uncontrolled entry of contaminants. So this is basically the idea behind this. What we're doing is we can't do anything. We can't put a filter on those uncontrolled holes that are all around the house. So what we want to do is shut that off, make it so that those holes are not letting bad stuff in, have all of the air that's coming in be going through something that we are controlling. And so now I'm going to stop that share. Oops, I didn't want to totally stop share. I wanted to just switch back to the presentation. But so there we go, back to the presentation. So now let's say we've got our house. And so what we're going to do is we're going to have this duct that's connected from outside and then to inside. So we would bring air from outside through this duct, which then pushes that air in. So that's our supply. That's pressurizing the house to try to shut off the impact of all of those holes that are just all around the home. So now we've got a different path that's controlled. And when outside is bad, get a filter in place to get rid of the bad stuff that was in the outside air before it can get in. So this is the basic concept behind it. There are a number of questions about it that we're going to talk about in the next few slides. But from a technical perspective, this is the concept. Pressurize the house by bringing outside air in through a controlled system and clean that air when that air is dirty. One thing we would need to look at is, if we are always putting this filter in place, you're going to use it up faster. So is there a suitable, friendly mechanism by which you can have the filter in place when you really need it and not worry about it when there's not much going on? And does that even matter? Maybe it doesn't matter. And so that is the basic concept. And now we'll switch. I think, Ellison, you were going to take this.
Yep, thanks, Paul. That was great. I really like. I'm glad you shared that app. As a sub team, we took, I think, the prompt from Tammy a few weeks ago and have marked out these near and midterm goals. On the left-hand side is March 2023, so within just a couple of months. The next middle column is August 2023, so a little less than a year from now, 3 quarters from now. And then May 2024, which would put us, almost a year and a half from now. So starting on the left-hand side, our near-term goals for Paul were to have the lab setup complete and be running cases or experimental conditions and have the house of pressure ready for use by March 2023. A few goals that Christian has articulated or that we've articulated that Christian would take the lead on are establishing clear criteria for what would indicate success of an intervention. So by what are we going to measure whether the technology is making a difference? We'd like to formalize the decision-making for acceptance or rejection of data that are used for the algorithm. I think Christian highlighted 2 sort of clear-cut or more extreme cases where there's clearly something going on and clearly just an anomaly in the sensor, but there might be some muddier waters to formulate acceptance rejection criteria around. And then finally, by March 2023, I'd like to have a list of measured outputs from other team members that we would want. So this is internally almost like what are we looking to learn or gain from other members of the team so that we can clearly communicate those early and often and not be surprising people with requests or talking across one another. And then for my part, by March 2023, be thinking about program interdependencies across this project and with our partners, and then be thinking about recruitment, where we're going to be recruiting homes from, what kinds of homes, what criteria might we need in place to have a representative data set or a data set that's representative of what we want. So those are our near-term goals. In the middle here, for a little less than a year out, we'd like to have a minimum viable functionality for all the subsystems. And so these include things like detecting an event, ability to send a signal to initiate an intervention, ability to filter, pressurize in the home space. So those are all subtasks that can be worked on and achieve success in, or high likelihood of success in, that when they come together, we don't want to be worrying about those being major points of failure. The full training data set, largely for what Christian is leading, should be ready. We'd like to understand the lifespan of filter options. I think this is something that Paul, maybe you initially brought up, to understand what the turnover in filters would need to be. It's partially just to know within our project so that we have adequate preparation for the project, but it will also inform, use or commercialization of something like this down the line if it's successful. We'd like to have a comparison of real world pressures to the pressures that are needed for functionality. So there should, hopefully the pressures needed for functionality are not way outside of the bounds of what we could achieve in real world settings. Or if we do learn that we learn it early enough, we can adapt to that insight. And then a full proof of concept for a grad student that would move the science to more the engineering realm. Before I touch on the last ones, Paul or Christian, is there anything you want to comment on or correct? Was I remiss?
I think the only one I would kind of expand upon a little bit is that in that March 2023, the list of measured outputs, that's like a two-way thing, right? Like,
yeah,
I want to make sure that I'm conveying to you what I might be asking for, as well as if there's something that you were anticipating that the physical bits and pieces and hardware and technology is going to be able to provide back to you, make sure that we know what that is. And I think there may be a bit of a discussion towards the end.
Yeah,
but
thank you.
I think my mind may be a little narrow just because we've been thinking about such of the detailed level that we may be missing some really low-hanging fruit of, oh, it'd be really useful if we had collected X, Y, or Z. And it's a minimal increase in effort and cost.
Yeah, no, that's absolutely right. Thank you. Paul, anything before I?
No, you're doing great. Go ahead.
Okay, so the last set of goals is a year and a half out from now, where we want to be with respect to both the technology that's being developed and understanding the behavior, understanding some aspects of behavior as it relates to the technology. So we want the filtration system to be working. We want the prediction system of events or the need for intervention to be working. And I think this came from Christian. I really appreciate this one. We'd like to be able to interpret failures. So when the systems fail, why do they fail? Can we differentiate between when the tech is failing and in what part of the tech is failing, or if it's a behavioral set of factors that's promoting failure? So failure mode differentiation. And then on the behavior side, we have two questions here. What survey-based metrics will we rely on to understand behavior with the technology, and what kinds of questions do we need to be asking to understand how people are engaged with the technology? I think that summarizes our goals. I think we were asked to think about questions that we'd want to try to see answered by going to the field. Like, what's the purpose of going to the field? There's many. Here are some questions that we thought of. See, I'm trying to think. I can start to go through them, I guess. How does variability change relative to the lab? So when we were thinking about this, oftentimes technology, when tested in a laboratory setting, exhibits a certain range of variability that tends to be narrower than the range of possible outcomes or performance indicators in the field. So we're interested in how variability in the performance of the technology changes once we move it from the lab to the field. What level of control do residents want to have with this system? What drives people to use it? How easy or not easy is it, and costly or not costly is it to retrofit homes to contain intervention systems like this? How does the technology perform with real aerosols relative to lab generated aerosols? What fraction of the time does anticipation of events actually help? And how powerful is the use of pressure differences for predictions and usage? And then finally, thinking about staffing, we were able to identify a few needs or resources that we already have. So Christian already has a SURE student. For those that aren't familiar, SURE is Scott's Undergraduate Research Experience. I think that's the right acronym. In any case, it's Scott, or the Walter Scott College of Engineering has a tranche of resources for early undergraduates, so freshmen, sophomores. I think that's still the target audience. I've had SURE students in the past. And these students are interested in research experiences, and the goal is to try to help them onboard into research experiences earlier in their undergraduate career than, say, their junior or senior year. So he may also potentially have another undergraduate who could provide some support. And I think we might get into more details around this after I wrap up. Paul would like to be providing more of his own resources or time in providing guidance on getting the House of Pressure up and running. I feel like most of what I would be doing would be best staffed with the postdoc or an RA under consideration. And I'm not sure that my staffing needs are as high frequency or sustained as either Christian or Paul's. And then Paul specifically called out the need to work with both Christian and Kaya to get the experimental design right, and that this is sort of a nearest term priority.
And so then this is the last slide we have. And so, a few other just minor, well, not minor, but a few other points that are not in the previous categories. One is, just as this session, I think, is doing, we need to continue to have PI level discussions that are identifying interdependencies. I think that has to be very intentional. Personally, I know that it's easy for us to just go off on our own thing and forget about what else is going on. And so having these sorts of opportunities to make sure that we're connecting the different portions of the overall program is, I think, going to be ongoing, really important. We need to identify what are the characteristics we're going to want in the field sample so that Ellison can be working on identifying appropriate homes for it. And what do we believe are the metrics of success? So those are discussions we're going to be needing to have ongoing, I think, among the entire team. We also have a couple questions for the team, assuming we have the system is working. Is there other information you would like us to be able to get? This was something that Christian referred to previously when he expanded on the one item on the kind of the March, August, May timeline. Yeah. While we're putting this together, is there stuff that other people really would like us to be able to learn? And the time to try to build some of that in is early, not late. So that, and then what will the rest of the team want to know about how did it work? So there's kind of, what do we want to make sure we're collecting when we're out there? And then what do you want to know about how did it work? Do you want to know how often did it run? If people decided to shut it off, occupancy, anything like that. And that's just a few examples. It's not like pick of those, anything that you might be interested in. No promises. We did not budget for an infinite set of options, but I think we would want to get as much in as we possibly could to answer as many questions as we can. So that is the last slide that we have. I can leave it up so I can go back to things if people want, or I think now we'd open it up for comments and questions.
Paul, I have a question.
Yep.
On your graphic there, you made it look like the filter is going to look sort of like a furnace filter. Is that what it's going to be? I mean, I'm wondering about the invasiveness of this filter. Is it going to be something where we're going to have to talk to our contractors about cutting into a duct to put this in here? Or, I mean, that can't really be happening if this is something that only is used sometimes, right? So I'm a little confused on this.
Yeah, it may or may not get integrated with the furnace itself. It could be standalone. If it was standalone, it would need to have its own fan, obviously, in order to be able to run. What we're working with right now in the lab is a fairly good sized diameter duct and then a relatively small filter in terms of its the face. I'm looking at it right now as a little bit more of a potential standalone system that's focused on moving air through a good filter. But you're right, it does have the appearance. It is a furnace type filter, but it's a smaller one that I'm starting with. These are some of the questions we need to answer in the lab. Can we do it with a smaller filter?
Okay, then if you're not connecting it to the furnace, wouldn't your pressures be less and that kind of thing? I mean, is it the furnace and air conditioning sort of designed to push, to push the air out and everything? But if you're having this be a smaller sort of auxiliary system, is that going to accomplish what you need it to?
It actually, in some ways, may be better because, yeah, the furnace or air conditioner is intending to push air in, but it's also pulling air back out. So without something like this, it would not have any impact on pressures. So because it's supposed to be pulling as much air into the return and therefore out of the house air to then circle back through before pushing back into the house. So what this does is it doesn't have the recirculation part. It's all outside. And then, so Tammy, you raised your hand, and then Paige, and then Erica.
So I want to comment on Lori's question that I think Lori's pointing out the invasiveness of what might happen. And that's something that we didn't consider in putting in the surveys. Like, would you object to somebody doing this to your house? I don't know. We've already got quite a lot in the survey, but I just wondered if that team wanted to take it on, or think about, or maybe at least connect with you. And then the other thing I want to mention, but don't want to get into now, is that there's a component of the project that myself and Dom are doing that's like the prediction of not whether the air outside is going to be polluted, but what an intervention would do to the home. And so we'll present on that later, probably next year. But the thing that you showed with the pressures was super cool. And then there's more to say on that. So I just wanted everyone to know that. I know you knew it, but I wanted the rest of the team to know that there's this other component.
Oh, if I can ask one more question, I'd like to know what are we envisioning here between what's the sensor, is how directly is that going to tie into this filter that you're going to have, and what's it look like? If I was a homeowner and and you showed this to me and you talked about it, I'd want to know, well, what's this piece and what's that piece, and and again, how's that going to affect my home, and where are you going to put that, and that kind of thing. So do you have any mock-ups of what your system is looking like right now, or is this too early?
So I have a couple of ideas on what it looks like. I might have sketched it on the back of an envelope at some point, but I don't have anything nice. But you're absolutely right, Lori, that people are going to want to know what this is. Where is it going to be? What's it going to look like? What do I have to do? All of those questions. And so and I think that's that, and the invasiveness, those are all things that we need to understand on the behavior side, on the human side, because without that, it's not going to work. But kind of the idea that I have is this filter that I'm showing here. The idea that I have is that it would not always have air going through it. This could end up being just a regular ventilation system most of the time, with sometimes this filter coming in when the air is bad. And there's a couple different ways that I've thought of to do it. One is to have kind of a bypass duct. So you'd have the main duct, and then you have a bypass duct, and that's where the filter would be. And so you'd have to have dampers that say, oh, air is outside is bad right now. So instead of just going straight through, go around the bypass. The other option would be to have something that's kind of like a gate, where it's got the filter is in some kind of housing outside of the duct. And when it says, oh, the air is bad, okay, put the filter into the duct. And then when the air is not so bad, pull it back out. That's just two ideas. This is part of the engineering that needs to be done, I think, kind of between next August and May, to have it be ready to figure out our options, and also get informed by what we may learn from the surveys in terms of what people are interested in. So I think that's one of the areas that's going to be so important for us to have ongoing good communication between groups.
I would think if it would be a filter like that, that it would need to be pulled every once in a while either by the homeowner or by the research team to see how well is it doing, and is it catching very much?
Yeah.
I know you'll have sensors in the home, but still, if I were a researcher, I'd be curious about how well it was doing, what it looked like, and would the homeowner then need to replace that periodically?
Yeah, and that's one of the main things, one of the absolute biggest things we're trying to get a sense of in the lab is at a certain level of contaminant, a certain contaminant level in the air. How long do these last? If this is something where if you got a wildfire going on, they have to replace it every 30 minutes, that's not a viable product. But if it's something where you can put it in and every 2 months they need to replace it, now we're getting more in the range of viability. And so that's a key, absolutely key thing to figure out in the lab before we get into people's houses.
The other thing I would add to this kind of discussion in general is, like, from a technology development standpoint, this can be a super risky project, right? We have a lot of interacting components, and so we're trying to take this approach of de-risking wherever possible. So I think in this project, we should view a lot of this as kind of modular technology pieces that interact with each other. So I think one of the plans we've talked about is, well, there'll be this sensing thing, and it will do an output that would go to filtration, and it would do an output that would go to pressurization, as opposed to viewing this as a ready for market product, right? Those are some really, really risky interactions there that all have to go super, super well. So we're trying to do this kind of as a core node or hub or whatever, and all these technology nodes that go off of it, so that if we find out in the next year and a half, wow, that's a much more difficult thing to implement than we thought, well, we can kind of carve that element out and pivot and focus on other areas. This really needs to be there's some central pieces that need to talk together, but individual components that are able to talk to each other, we're not going to be in a product design phase here. It's going to be a functional element that we get to talk with another functional element, just from a risk standpoint. Otherwise, we set ourselves up for major disappointment. So, Laura, you bring up some really good points there.
Yeah,
I think also when we're talking to where this goes to is when we're talking to our potential household participants, we need to be really good at conveying that we're not implementing a product, we're implementing some technological things that could turn someday into a product.
okay, Paige.
Yeah, so actually my question was similar to Lori's, but I think the second piece of it that I would be interested is I have a hard time like visualizing like what this looks like for the resident. So can you talk about like what are the possibilities of like what the technology looks like for them? Is it like a thermostat? Is it like an app on their phone? Do they have to go to their like basement? Like just yeah, hypothetically, what would this look like for them?
Yeah, so it's going to have to be automated in some way. And one of the questions that we have is how much control do they want? You know, people often say they want control over things, but they don't want control over things. They don't want to have to be monitoring the temperature inside the refrigerator and turn it on every time it starts to warm up. They want the refrigerator to just keep things cold, period. So that's one of the questions we have. So, in a world where they let it be like a thermostat controlling the furnace for heat, they would let Christian's predictive sensor that could be in something that looks sort of like a thermostat. They could let that predictive algorithm say, oh, things are getting bad outside, trigger this system, and have air go through the filter in whatever mechanism it is that we had. The way I've got it drawn here, this would be something that might come into a basement, say, or a crawl space, or it comes in a little bit above grade, has to be above the snow line, and then deposits into the house. There are systems that deposit into the return duct of a furnace, and so maybe it doesn't go directly into the house, but then you've got to use the whole furnace duct system, and it may or may not work as well. But I envision if it was the way I would like it to be, it would be something like a thermostat. It would just be a contamostat or whatever it is.
Yeah, I kind of agree. I think long term, if this was like, if we view it from a productization lens, yeah, you'd envision it being incorporated into a thermostat or something like that. For the scope of this project, it's likely going to be like a standalone box with a little screen. I'm going to do everything possible to try and convince this group not to go down the app control route, but that's a negotiation we can do during the give and take here in the next little bit.
I'd be much more inclined to have app information than app control. Erica?
Yeah, I have a couple of questions. I guess the first question that I have is, you talked about being able to differentiate between system failure and behaviors that caused like a failure mode. So I guess my question is, like, what behavior would someone do that would be a failure?
Turning it off, for example. Like, we were gonna have to give them an override just from like an ethics, safety, all those things, right? So we need to have that. So like a simple example would be, well, did the algorithm not pick up a problem? That'd be like, you could say a failure. Did the algorithm pick up a problem, try to do filtration, and the mechanical fan didn't run, which is like a type of failure? Could it be, it had a great system and, you know, Mary Sue unplugged the system, right? Those are different failure modes. And there is a desire or a need, I would argue, to be able to differentiate between those. So I guess failure is probably better characterized from the standpoint of, we are saying that correct functionalities, our system is able to protect the home. People intervening or intervening and changing that prevents our system from doing it. Our system not working prevents it from doing that.
Yeah, I'll just throw in, there's one failure mode that is sort of a bridge between technology and behavior, and that is the filter getting clogged and did the people not change it.
Mm-hmm.
Marilee?
Yeah, to follow along with what Paige and Erica have said, would there also be a failure mode if they, and I'm just kind of envisioning what that the outside pipe is or whatever, if they put something in front of that, if they impeded the flow?
Absolutely.
Okay. And then I was wondering, we talked in our group about the homeowner being able to see, not necessarily having massive control over the system, but being able to see that it's working, that there's like a green light or there's something that they can see that helps to build their trust in the system. They could also help with, it's not working. I mean, because one thing which would be interesting to know would be, thinking about when technology's in, beta phases, funny things happen, that, how they respond to that and how comfortable they are with the fact that, they're an early adopter. And, can they see stuff? Can they let us know how? And sometimes that can be really good because they feel like they're part of the process. And so they can invest in that. And so I know we talked about a little bit about what, like, kind of like what that screen would look like, or something that they would see. I mentioned that we have a radon system in our house, and we can go out and we can feel the pipe. We know the fan's still on. We can hear it just a little bit. And then there's an indicator that kind of shows how much is being pulled. And that when we first got that fan, I would often, when it got out of the car in the garage, kind of look up and, okay, it's still going and things. And so, those kinds of indicators that could help with trust, with willingness to adopt, that sort of thing. I was curious if you guys were thinking of, I know you had thought about that stuff yet, or we would have a chance to kind of discuss that at a later part in the project.
I would say 100% in our minds. And one of the things I wanted to get feedback on, because like I've gone back and forth from a research standpoint. Let me first say, feedback is surprisingly easy to give if you set up the system early on. turn on the light, right? We're going to be connected likely through some data pieces so we can have a dashboard. I just don't like the apps because it's been a royal pain getting CSU to agree to have anything put on an app that associates CSU's name with it. But dashboard or website or lights or things like that, all that's good, or all that's possible, I would say. Where I've gone back and forth, and I think this is where the other members of the team could really play a role, is I could make a case that we want feedback just because all the things you said. I could also see a case that we want this to be as discreet as possible because we want it to be as small of a behavior change as possible. Like, we don't want people interacting with our system. I could argue either one of those cases. And I think it's one that A, I'd love to get your feedback on, and B, we should talk about early on. Do we do both? Is this like an A-B, but we don't have a study size to do that? Is it we enable the feature or enable the functionality there, but make sure that we have an ability to turn it off if we figure out that people don't like it? Like, those are the thought processes I think we need to do early on. And I don't know, like, I don't like dealing with people. I just want the technology to do its stuff. So I want feedback from you guys about what you think would be most suited for your research questions.
Yeah, and I would echo that. I think that there's no shortage of recognition that some of these things are going to be vital, important, and needed, and designed in to the overall system early. Just, you know, how does it look in a way that engages people? You know, we don't want to be so complex that they just have their eyes roll back in their head and fall over. I think if we told them, here it is, and you've got no interaction, no say in it, and it's good. If we want them to change the filter, sometimes we're going to have to give them some indication that they need to change the filter. So there's got to at least be a little bit of interaction. So how does that look in a way that is approachable and brings them in instead of keeps them out?
Could you have an indicator on your somewhere that shows that the furnace filter needs to be changed?
There are thermostats that do that, and I think people usually ignore it. So I think we need something that's a little better than what's often on thermostats. But yes, some kind of indicator that says, hey, it's not able to do its job right now. I think it's
kind of like, or like when you know, smoke alarms, you know, you're supposed to replace your batteries periodically, not when they're, but you know, they beep. It's highly annoying. So I don't know that we wanted to do that, but that is that thing that, well, you can also rip it off the wall, of course, but yeah, something they won't ignore, but that they will attend to. This all sounds good, and I think there could be some really cool ways to kind of engage them such that they know it's working and they're kind of excited about it, and they might even show it to their friends. Here, see what we've got. Here's our little indicator of that. That would be fantastic.
Yeah.
Yeah, maybe a flashing light would work, because if you're hard of hearing, you may not hear it beep, but a flashing light might get their attention. Just a thought.
Yeah. So
one that has
just
one thing to kind of toss out there. We have all things considered, it's a pretty small real world validation we're going to do here, right? Just budget and time and all of those things. So the other one I really think would be good for us to think about is, well, what sort of things can we kind of sneak in here to collect pilot data that would justify a proposal to do some of these things? And that's where I think some of these other metrics that we might be able to collect data on, assuming it's ethical and it's not diverting from our primary goals and things like that, would be great. Like, I looked and I found very little information about people's willingness to use smart thermostats beyond the companies say they're willing to use them, right? So what are some of those other measurements that we could do to, like, that's an easy follow-on proposal. There's an easy request for an expansion, that sort of thing.
Can I ask a question related to that? How much like wiggle room do we have for there to be like sort of multiple iterations? Like I I forget off the top of my head how many houses we're talking about, but could we have like 2 versions and see how people engage with the systems differently based on like a minor change? Or is that something that would be like substantial extra work for you?
From a technology standpoint, if we make proper choices at the proper times, some things are possible, right? Where those version issues I have seen come up before is because at the 11th hour, it would be really nice if we could do A or B. Like, oh, I've already made 100 of them. Like, we're too late. Some things, yeah, that's where like the ability to turn on and off the indicator, or a cover that hides the indicator in some cases and doesn't in others, like very open to the discussion earlier, right? This is the time for us to think about those variations.
Yeah.
I think we would have to think very, very strongly or carefully about would we actually have any sort of statistical power left over if we're starting to split our cohorts here in our populations. But that's a different set of questions, I guess, to think about. And there may be an opportunity that we say, well, 95% of people are doing this, and 5% of people we know are just from a pilot opportunistic thing. So
Yeah, so I agree. I think that there is some ability to have, different versions. Like I talked about 2 different ways to send the air through. Is it a gate pushing the filter in, or is it a bypass? That's an example of we could try both and see if there's one of them fails more or not. One of them people like better or not of the small sample we have. That's just one example. I think, yeah, if we have good open communications and discuss these things at the earlier stages, all kinds of things are conceivable. And Paige, did you have another question, or was that your question you had your hand up for?
I had another question, but I know that we're kind of at time, which was just so maybe we can talk about this later, but does this kind of change to the system have other effects besides just the infiltration of outdoor contaminants? Like, does it change energy efficiency in the home or something like that? I'm just trying to think about like long term when we're messaging this. Do we have to have people who are bought into the concerns about indoor air quality to get them to do it? Or are there kind of other impacts it has that could be used to kind of sell it as like a bundle of good effects?
100% going to have impacts, right?
Yeah.
If we're turning on and off their fan. Now, I think we may be able to make a case that there's times that technologies like this might actually be beneficial from those things, as compared to the norm of if you follow like the EPA's recommendation or the Forest Service. There's a forest fire, have your filtration on right now, right? That's a big increase from baseline usage, but we may be able to be better than the blanket statements that organizations make of, well, if there's a fire in the area, run your filtration system. Like, we can be selective and run it only when it's necessary. We wouldn't be better than not running their system at all, but we could be better than we'll turn it on for June through September, which is forest fire season. Does that make sense?
Yeah.
I was going to do a slide at the end, and I thought it was going to be too much diversion, but I've started to put together like a list of papers that I think would be interesting around this topic. And one of them is exactly that, just like from a thought exercise standpoint, like what is the kind of techno-economic break-even points? How much would you have to value air quality in your home to say that you're going to run your system more?
Yeah. Yeah. And if you have a fan running that's bringing outdoor air in, just like if you have a fan running that's taking outdoor or indoor air and throwing it out, you have both the power required to run the fan and you have the energy required to condition the air that you have brought in from outside. And so there's certainly an energy efficiency implication, and people are often resistant to ventilation systems because of that. And I've in my time working in training for almost 20 years, we've come up with some ways to try to educate people and show that we're not talking about hundreds and hundreds of dollars. We're talking about a few tens of dollars a year for typical systems, but this might be bigger. So there are certainly questions. And then this is part of why I think it's going to be really important to not just assume that this thing runs all the time because of the occasional time when it's bad outside. that we're really focused on when there is a need that people can say, there is actually a reason for me to do this. It's not just about energy.
If I could ask one more question. Would you then, are you thinking about having an outdoor sensor that would trigger the filter to trip so that there wouldn't be that need, that manual intervention to make the system work? So we're
Yep.
talking about an outdoor sensor and an indoor sensor as well?
Correct. Hopefully, in certain regions, we can leverage outdoor sensors that already exist, because there are certain communities where it's spatially dense enough that we might get away with that. But that is one of the pieces to be figured out in these kind of near term. How close would that sensor really need to be? Is my neighbor's good enough? Is the one down the block good enough?
Yeah.
But we can leverage that purple air data set that I referenced at the beginning to answer some of those questions. But yeah, we have to ideally know outdoor to have this be really effective.
Yeah.
We can also say, right, one of the nice get out of jail free cards we have, if we find out that the anticipatory control does not work, all of these same things still somewhat can work from the standpoint of, well, it's starting to be bad inside, do my intervention. Way less elegant, way less effective for pulse pressurization, but something there, right? We do have a few ejection paths if certain key parts of the technology fail early in the validation process.
Yeah. So I do want to recognize that, you know, Tammy is always saying she wants to end at 12:50, not 1 o'clock. She's not here to enforce that, and we've gone to 1 o'clock, but it is now 1 o'clock. So I do encourage, I think it's been a great discussion. I really appreciate all the questions. You're hitting on a lot of the things that I know are super, super important and are not our core areas of expertise, but that's why we're a team. So if there's more questions we didn't get to, send them along. You know how to get a hold of us, and we'll keep the conversation going. All right, and I will stop recording.